Here we see the meticulous process of separating valuable components like copper coils and charging ports from the main chassis.
As the shredders break down old circuit boards, a sophisticated dust extraction system captures the resulting haze. The final stage of separation reveals the smallest particles. These fine powders contain valuable metallic elements, ready for reuse.
Here, the density separator uses brisk airflow to sort materials by weight. Lighter plastics are carried away.
This is the final stage, where the separated streams undergo a meticulous quality check before being sent for refining.
The recycling process allows us to reclaim precious metals, like the gold seen here.
The fine greenish gold PCB powder is collected by this vibratory system before moving on to the crucial chemical processing stage.
This wide shot shows the filtration array, where dissolved precious metals are separated from the incoming waste material. This facility represents the cutting edge of resource recovery,
processing tons of electronic waste every day. The amber solution clears as the denser gold particles migrate downward, creating a valuable sediment layer atop the base metals.
To remove the base metals, we introduce the flux, causing this exothermic reaction and bringing the slag to the surface.
Here we see the final stage of refining, where the impurities, or slag, are carefully skimmed off the surface of the purified gold.
Final refinement with oxygen injection ensures ultimate purity. The molten gold bubbles vigorously during this chemical purification process.
Here we see the final stage of refining, where the impurities, or slag, are carefully skimmed off the surface of the purified gold.
Final refinement with oxygen injection ensures ultimate purity. The molten gold bubbles vigorously during this chemical purification process.
Recovered from tons of electronic waste, this stream of pure, molten gold represents the success of the reclaiming process.